Hello students, I am Nilima J. Solomon. Welcome to Unlocking Physics. Through this channel, I would be helping you in studying physics for class 12 CBSE. Now let's get on to the roadmap of our journey, that is question paper design in paper pattern. Here the number of questions and marks according to the weightage. We will have 20 questions of 1 mark each. These 20 questions are further subdivided into 10 MCQs. They can be reason assertion type also. You will have 5 fill-ups and 5 very short answer type of questions. Then you have 7 questions of 2 marks each, comprising of 14 marks. They will be short answer type of questions. Then again 7 questions of 3 marks each, weightage 21 marks. They are long answer category 1. Then you have 3 questions of 5 marks each, 15 marks weightage, long answer questions, category 2. So total number of questions 37 and weightage 70 marks. Our first unit of CBSE class 12 syllabus is Electrostats. In this particular unit, we will be majorly covering the 4 heads: charges, fields, potential, and capacitance. These two concepts of charges and fields we will be covering in chapter 1, and potential and capacitance, these things we will be covering in chapter 2. So basically chapter 1 and 2 both will comprise of the first unit, electrostats. Let's come to the definition of electrostats, the name of the chapter. It is basically, you can start noting them down, study of force, field and potential arising from static charges. It is, according to NCERT book, the definition is study of force, field and potential arising from 2 keywords: static charges. With the advancement of technology, we have been able to discover hundreds of elementary charges. Out of all these hundreds of elementary charges, 3 most common and very important elementary charges which are well known to you, we have already studied them in previous classes, are electrons, protons and neutrons. Electron having a rest mass of 9.1 into 10 to the power minus 31 kgs. Protons 1.674 into 10 to power minus 27 kgs. This can be even 2 also. 1.674 into 10 to power minus 27 kgs. Now, if they have these masses, we can understand, if I take 2 electrons and place them at a distance of 1 centimeter, what do you think? How will they interact with each other? As I said, they have some rest masses. They will have definitely some gravitational force, which is G me square upon square of distance. Substituting the values, so the situation which I have given to you is 2 electrons. It's of course a hypothetical situation, kept at a distance of 1 centimeter from each other. Now what do you think? They will experience some gravitational force. Why? Because they have masses that I have already given you. So the gravitational force which they will experience, 6.67 into 10 to the power minus 11 units Newton meter square upon kg square into mass of electron upon square of the distance, which is 10 to power minus 2 meters square. And the value comes out to be 5.5 into 10 to the power minus 67 newtons approx. Now my question is, what type of force is this? Of course, the answer is F gravity has always been attractive. So these two electrons are attracting each other with a force of 5.5 into 10 to the power minus 67 newtons. But in actual practice, we know they are not attracting each other. In fact, even a small 6 to 7 standard student will tell you if two similar charges are placed, they will repel each other. That means if we go into the understanding of the concept, that means I said if two electrons kept at a distance of 1 centimeter, they are under the action of gravitational force, and this gravitational force is attractive. But to our surprise, these two electrons are not attracting each other. That means they are repelling. When they repel each other, it is the indication that apart from gravitational force, there is some other kind of force which is acting, or we can say there is some other kind of force which is active in these electrons. So my concept is, if two electrons kept at a distance of 1 centimeter, they experience the known gravitational force, and this gravitational force is attractive, and this gravitational force is basically due to the masses they possess, and the magnitude of this gravitation, this mass is 9.1 into 10 to the power minus 31 kg, and the magnitude of this gravitational force, we have seen it is approximately 5.5 into 10 to the power minus 67 newtons. Still, this magnitude of gravitational force is not enough to make them attract each other. As I told you, they are actually repelling each other. This repulsion is the indication that some other force, some other kind of force is active in between these electrons. Now, the question arises, which is this force which is making them repel each other? With the advent of studies, again these two electrons in a situation, scaled down situation where I've kept them at a distance of 1 centimeter. Now this F gravity, as I told you, its magnitude is 5.5 into 10 to the power minus 67 newtons. And as we have concluded that apart from this gravitational force, there is some other force which is making them repel each other. Now, with the advent of studies, it was known that this force which is making them repel each other is electrostatic force. This gravitational force is due to mass. That is, mass is responsible for gravitational force. Then there should be another fundamental identity which should be responsible for electrostatic force, and that is charge. If we talk about F gravity and F electrostatic, the magnitude is the magnitude of F electrostatic. If we can write the magnitude, it comes out to be 2.3 into 10 to the power minus 24 newtons, and it is much greater than the gravitational force. That means we are already familiar with the 7 fundamental units: length, mass, time, luminous intensity, electric current, amount of substance, temperature. Here mass is responsible for gravitational force and current, which is written as delta Q by delta T, is responsible for F electrostatic. From our past discussion, we can conclude that if two electrons kept at a distance of 1 centimeter, then they experience electrostatic force of 2.3 into 10 to the power minus 24 newtons. If two protons, which are positively charged, they are also kept at a distance of 1 centimeter, they experience F electrostatic. Magnitude wise it's same, 10 to power minus 24 newtons. And if two neutrons are kept at same distance of 1 centimeter, they experience F electrostatic equal to 0, and they experience only F gravity, which is equal to 1.9 into 10 to power minus 16 newtons. This gives us a very important conclusion, that the magnitude of electrostatic force both in case of electrons and protons is exactly similar. That means we can conclude that the magnitude of charge, same magnitude of charge is on both electrons and protons. And about neutrons, that charge is 0. Now we have come to a very crucial and important concept. We have concluded that gravitational force is due to mass and electrostatic force, the causative factor is charge. So in the coming lessons, we will be concentrating on this key factor charge, which is giving rise to this electrostatic force, field, potential, capacitance and all these things. So basically charge, definition, first thing is definition. It is fundamental, let us write the definition here. It is the fundamental intrinsic property of matter responsible for electrostatic forces. By definition, charge is the fundamental intrinsic property of matter responsible for electric forces. In the next class, we will be studying different aspects of charge. That is, its units, its SI units, CGS units, dimensions, properties, how to measure charges, how to charge the conductors and dielectrics, and so on and on. For that, we have to look on to the next lessons and next episodes of the same topic. Thank you.